Alright, today I'll be discussing the addition formula. What is that? So let's say I have sine, then two angles added inside sine. Can we express this as some combination of sine of those individual angles or cos of those individual angles? We can. How? Let's say we have one angle as alpha, the other angle as beta. Okay, so that we have this big angle alpha plus beta. So sine alpha plus beta, what is that? We have to figure that out. So first of all, let's drop a perpendicular from this point. Just get rid of this extra line. Let's drop another perpendicular from here. Let's redraw it. Let's drop a perpendicular from here and a perpendicular from here. Okay, so this is 90 degrees, this is 90 degrees. Now let's drop a perpendicular from here. This is 90 degrees again. Let's put some names. Let's say O, A, B, C, D, and how about this point? Later. And let's plot another perpendicular from B to AD. Why? We'll explain in a bit. And let's name it E. Okay, let's also name this point as F. This point. Okay, we're all set. What is sine alpha plus beta? As we know, sine of this angle in a right angle triangle, which is AOD, sine of alpha plus beta would be AD over OA. OA is the hypotenuse. Let's name OA as capital H because we are going to be using OA quite a lot. So sine alpha plus beta would be AD over H, which is OA. Okay, can we split AD? See that AD is AE plus ED. So I'll write sine alpha plus beta. AD is AE plus ED. So AE plus ED over H. All we have to do is find something for AE and ED in terms of sine of alpha, cos of beta, or something like that. We'll try to do that. How do we do that? First of all, let's see. Consider the triangle OFD and AFB. See that this angle and this angle are vertically opposite angles, hence they're the same. This angle is 90 degrees, this angle is 90 degrees. Same. Since two angles are same, the other angle, which is this one, has to be same as alpha. So this is alpha. Okay, fine. Why did we do that? We'll figure out in a minute. Now let's consider this triangle OBA. What is AB? Can we express AB in terms of this angle beta? We can. How? Sine of beta equals AB over H. AB over H, right? Or I can write AB as H sine beta. Fine. Now consider this triangle AFB. Here this angle is alpha. Actually consider this triangle AEB, not AFB. AEB. This angle is alpha and we have the side AB, which is already known. So can you find AE? AE would be, sorry, let's do cos alpha first. May not be obvious directly if I write AE. Cos alpha is AE over AB, which is the hypotenuse. So AE, which is this guy, over the hypotenuse AB. This is a right angle as well. So this is the hypotenuse. Okay. So this gives me AE equals AB cos alpha. I was after AE because we have AE here, but we have still got AB here. We want to get rid of AB. So use this. AB equals h sine beta. So AE is nothing but h sine beta cos alpha. So one of the parts we have already got in terms of known quantities. Let's do the same for ED. How do we do that? Note that ED is same as BC. So this makes life a bit simpler. So we just have to find BC. So consider the triangle OBC. If we consider triangle OBC, we have sine of alpha equals BC over AB. Sorry, OB. Right? This gives me BC equals OB sine alpha. Now we have to replace OB. For that, we have to go to this triangle, the top triangle, OAB. So using that, if we consider cos beta, that is going to be OB over H, base over hypotenuse, or OB equals H cos beta. Now we are going to replace OB here with this H cos beta. So BC, which is equal to ED, equals OB sin alpha. OB is this. So H cos beta sin alpha. We have got the other candidate. Now we have to substitute these values here. So sin alpha plus beta, which is equal to 1 over H AE plus ED. Right? What is AE? AE equals, from here, H sin beta cos alpha. So 1 over H sin beta cos alpha. And what is ED? H cos beta sin alpha. We can get rid of this H with this outside H. So we end up with sin beta cos alpha plus cos beta sin alpha. A nice and elegant formula for sin alpha plus beta. Sin alpha plus beta. So why this formula is important is you can, for example, find values of sin 75 degree without using calculator. How? If you know the values of sin 30 and sin 45, you can find the values of cos 30 and cos 45 and just use this formula. Sin 75 is sin 30 plus 45. So you can split that into sin 30 cos 45 plus cos 45. So cos 30 sin 45, like that. Okay? You can do that exercise yourself.